This is Lecture 7 in my series of Statistics for Nuclear Medicine. In the last couple of lectures we've talked about tests for comparing means of distributions. Now we get on to how to compare standard deviations. When we're comparing distributions, we may take account of the fact that two different distributions may have different locations, as shown by the yellow and the blue distribution here, which have got different means. In Lecture 5 I talked about parametric tests for comparing two distributions based on comparing the means of each distribution. And in Lecture 6 I talked about non-parametric tests where we didn't calculate the mean, but we compared the central location based on ranking of the measurements. We also have to consider the fact that distributions may have different spread. Even if they've got the same mean, they may have a different width, a different spread of the distribution. That's what I'm talking about in this lecture. Parametric tests for measuring the spread are based on comparing standard deviations. They're often called variance tests because, of course, the variance is just the square of the standard deviation. There are also non-parametric tests based on ranking, and I'll just mention those. In looking at parametric tests for comparison of standard deviation, we can consider tests that are based on measuring the difference in the standard deviation, or variance. It doesn't say anything about the means. The means of the distributions may be the same, or they may be different. I'll talk about a single sample test, which I cover in part 2 of this lecture, which is used to compare the sample standard deviation with a known population standard deviation. That's the chi-squared variance test. In part 3 I'll talk about a two-sample test, which is used to compare the standard deviation of two samples. That's the variance ratio test, sometimes known as the F test. There are also non-parametric tests, which are used if the data are not quantitative or not normally distributed, because then we can't use parametric tests and we have to use non-parametric tests as an alternative. There they compare the spread of the distribution between the two samples based on differences of scale or based on ranking the data. The Siegel-Tuckey test requires ordinal data, that is, categories that can be arranged in increasing or decreasing order. And the two samples must have the same median for the Siegel-Tuckey test. The Moses-Rank-like test requires interval data, that is, quantitative data, numbers rather than categories, because we have to take the difference between numbers. But for the Moses-Rank-like test, the two samples can have different medians. I don't have time to cover these non-parametric tests in this lecture, so if you think you need to use them, you can look them up in textbooks. So that's the end of the introduction to this lecture.